Let's make another video.
You consider yourself to be a brunette as opposed to a brown hair?
I.
That's accurate. That's the thing. Somebody asked you like that.
I'm a brunette with shades gray.
Like a man, could you call it brunette? Just want to clarify.
I don't know what you're talking about. Let's look at this. Let's look at this function right here. Now, what is the main overriding function you see? You see a cube root? I don't see a cube root.
Cube.
I see a cubing function, which means he looks like what? No, he's not Cuban. There's no missile crisis going on here. But we know that the shape for this guy should be something that looks like that. What else can you tell me about it?
The vertex is down 5 on the x-axis.
This guy doesn't really have a vertex, so I'm going to have to stop you on that.
What do you call that? That little inflection. That little
It was a point of inflection. It is a point of inflection, but I'm not sure it has a special name like a vertex. I don't.
So what do you call it? The little point thing we're in the middle?
I always call
When I
it.
said vertex, did you know what I meant?
There's no vertex here, so no.
So you don't know what I'm talking about.
I always call it the base point.
The base point. This is a base point, south 5 on the x-axis.
South 5. We're going to go down 5, but what else?
Right 4.
So down 5, right 4. The 1/2 tells me that I have a compression. Is that right? So I put everything together now. You know, just like in all the other videos, let's just keep doing it. Let me put the original guy right here. 1 cubed is 1, 2 cubed is 8, -1 cubed is -1, -2 cubed is -8. So your basic shape is this guy right here. Now, let's make the adjustments. Down 5 and right 4, so down 5 to the right 4 is right there. So here's what I'm going to do. I've already used the down 5 and right 4. I don't need to worry about that anymore. Don't worry about it. I'm going to make my little crosshairs here so I know what my new origin is. So my key points are going to be 0, 1, 2, and so on. But notice I've got the 1/2. So not only will you have to cube, but you're also going to have to then multiply times 1/2. So what's 1 cubed? 1. But what's half of that?
Half of
1 half. What's 2 cubed?
8.
2 cubed would have been, excuse me, 2 cubed would have been all the way up here at 8, so that's 8 units up from that horizontal line, but what's half of that? 4. What is 3 cubed? 27 somewhere off the
13.
page. Half of that is 13.5. Can I fit that on here?
Yeah, it'll fit.
So 5 and 8 is 13.5. Right?
With the 2?
The
Why is it at 2 and 4?
2 cubed is 8.
Yeah.
But I've got the 1/2 here.
What's
So
that
half
red
of
dot?
8 is 4. What?
What about the red dot that's under 6?
Here?
Under the number 6?
Right, because look.
That's the actual point.
You're up.
Using the x as a reference.
Oh, okay. So
That's
You're
the
up
but
4
you're
units
testing it
here.
so that
Oh, and then plus 1.
You're up half a unit there,
Okay.
and this is 13 halves because that came from 27 over 2. I keep hitting this. So back here on the other side, you've got what would have been -1, but now we're doing half of that guy. -2 cubed is -8, but half of that is 4. So these are my key points. It's going to be a little bit flatter and a little bit wider than what we used to have, although it is a cubing function. So it's going to be steep anyway. What kind of questions do you have about that? You have to know your key points And notice, once I went down 5 and right 4, I didn't need to worry about that anymore. I then had to worry about being cubed and doing my compression. So 1 cubed is 1 times a half, or divided by 2 is 1/2. 2 cubed is 8. 8 divided by 2 is 4. 3 cubed is 27. 27 divided by 2 is 13.5. And we can orient these guys on the other side. Now this guy doesn't have any origin symmetry anymore, does he? If I were to take this guy and turn him about the origin, he's not the same. But he does have symmetry about this point right here, about that base point that we moved. So whatever you go over and up, you're going over and down. And we'll have some other graphs that have that same kind of symmetry. Because once you move it off, if it had origin symmetry, when you move it off, it's still going to exhibit symmetry about that new point. And here is what the real graph looks like. So you guys see that matches up? You got your key point right here at 4, -5, and then the shape stays the same.